In this series of videos, I'll show you how to make a 3x3 Rubik's Cube solver. This Rubik's Cube solver can take pictures of the cube to recognize current status and solve it. It can also randomly scramble the cube from a solved state, then solve it. In this video, I will talk about hardwares. The hardwares include Arduino Mega RAMPS 1.4 control panel, a stepper motor controller extension board, 6 A4988 stepper motor drivers, 6 stepper motors, 12 voltage AC to DC power converter, DC power connect cable, and 3D printed parts. I'll start with controllers. Unlike the remote control car project, I didn't use Raspberry Pi. Instead, I used the Arduino. The biggest difference between Raspberry Pi and Arduino is that Raspberry Pi is a microprocessor-based mini computer, while Arduino is a microcontroller board. As a mini computer, Raspberry Pi has all components that a computer has. It needs an operating system to run. You can use all kinds of different programming languages to write code for it. It's also more powerful than Arduino. Arduino doesn't need an operating system. You upload the firmware to Arduino, which tells Arduino what to do. Because of this difference, Raspberry Pi is good for complicated or resource-consuming tasks. For example, multitasking, sending an email, running machine learning algorithms, etc. Arduino is good for repetitive tasks such as controlling garage doors, reading from sensors, etc. If you want to read from a sensor and control the garage door based on the reading, Arduino can do the job perfectly. But if you want to read from a sensor, then read from the camera to run a face recognition to see whether it's a person you know, then decide whether to open the garage door or not, and at the same time send an email to you, then you'll need a Raspberry Pi. However, although Arduino is not as powerful as Raspberry Pi, it has its advantage when doing controlling jobs. It has built-in libraries for low-level control, so you only need to focus on the high-level logics. Remember in the self-driving car series of videos, we used one whole video to explain how to calculate duty cycle and construct a message to send to the servo motor to control it to move to a certain degree. With Arduino, it only needs 2 lines of code. One to attach the motor, one to write the angle. Another difference from the self-driving car project is that here I use a stepper motor instead of a servo motor to move the Rubik's Cube side to a certain position. This is how a stepper motor works. First, the top electromagnet 1 is turned on, attracting the nearest teeth of the gear-shaped iron rotor. With the teeth aligned to electromagnet 1, they will be slightly offset from right electromagnet 2. Then, the top electromagnet 1 is turned off, and the right electromagnet 2 is energized, pulling the teeth into alignment with it. This results in a small rotation. Then, the bottom electromagnet 3 is energized. Another small rotation occurs. Then, the left electromagnet 4 is energized, again a small rotation. When the top electromagnet 1 is again enabled, the rotor will have rotated by 1 tooth position. In this example, there are 25 teeth. It will take 100 steps to make a full rotation, so each small rotation is 3.6 degrees. This is why it's called a stepper motor. It can control the angle very accurately. All 3D printers use stepper motors. The stepper motors I use are NEMA 17 with a 1.8 degree stepper angle. One thing to note is the way the motors are wired. The motor has 2 coils, 2-phase motors. Each coil has 2 cables. The 2 pairs of cables may be connected with a straight connector or cross connector. This must be consistent with the wires in ramps, which use a straight connector. Otherwise, the motor won't work. Unfortunately, my motor's wires are not consistent, so I had to recrimp them. The stepper motor can be connected to Arduino and controlled through a stepper motor driver. The connections look like this. We need 6 stepper motors for the Rubik's Cube solver. As we can imagine, if we connect all 6 motors to Arduino in this way, the wiring will be very messy. Instead, I use the RAMPS 1.4 control panel. It's an Arduino Mega Shield. You can plug it right on top of Arduino, just like Raspberry Pi's head. RAMPS 1.4 is designed for 3D printer control. It provides very well-organized interfaces for all components a 3D printer needs. Motors for X, Y, and Z movements, motors for 2 extruders, fan, hot end, bed, display, temperature detection, etc. It only costs less than $10. Here we will only use a stepper motor control. Now let's look deeper into this controller board. Power supply. RAMPS 1.4 has 2 sets of power inputs, 12 voltage 11 ampere and 12 voltage 5 ampere. The 11 ampere power is only used for heating a 3D printer's printing bed. We don't need it. RAMPS 1.4 can provide power to Arduino, so we don't need power connection for Arduino. Stepper motors. These are the sections where you plug stepper motor drivers in and connect motors to. The 5 sections are for X, Y, Z, extruder 0, and extruder 1. These jumpers control the precision of motor movements. To get the most precise stepping, insert all 3 jumpers. The motor drivers go to these positions. Make sure the orientations are correct. The potential meter should be facing away from the D8, D9, D10 side on the RAMPS 1.4 shield. Then plug the motor wire to these positions. The directions doesn't matter. It controls which direction the motor will run. You only need to make it consistent for all motors. Since the Rubik's Cube solver needs 6 stepper motors, we need to extend the board to connect the 6th one. First, we connect the motor control extension board to the RAMPS. We get the 5 voltage power from the RAMPS aux2 group of interfaces. We connect the 9 voltage power input to the RAMPS D9 positive, which is for fan, and the ground to the RAMPS input power ground. This way, the 9 voltage power is always on. If we connect the ground to D9 negative, it will only be on when the RAMPS receives the command to turn on the fan. For control signals, we connect S, D, E to D40, D42, and D44 in the aux2 group. Then we plug the motor driver in and connect the motor wire to here. After connection, except for the motors, it looks like this. In addition to making the wiring much neater, another benefit of using RAMPS 1.4 is that we can use open source firmware to control the motors. Here I use the Marlin, which is an open source firmware for 3D printers. We store it to Arduino. Then we can send commands as G-code to Arduino. I will talk about G-codes later when introducing the software. Installing Marlin to Arduino is pretty straightforward. First, you download and install Arduino IDE. Second, you go to Marlin's website to download the zip file, then extract it to a folder. Third, you open the marlin.ino file in the Arduino IDE. Fourth, you connect the Arduino to your computer through USB cable. Then click the Upload here to upload the firmware to your Arduino. But before uploading, we need to do one more thing. Remember the RAMPS 1.4 control board by default supports 5 stepper motors. We added the 6th motor as the 3rd extruder. We need to configure it before uploading the firmware. When you open the marlin.ino file in Arduino IDE, the configuration.h file should also be opened. Find the section which defines the number of extruders. Change it to 3. Next, we need to configure the pin settings for the 3rd extruder. Open the file pins.ramps.h with an editor. The file should be located under Marlin pins ramps. Find the section that starts with steppers. You can see the pin configuration for X, Y, Z and the 2 extruders. Remove the CS pin lines for E0 and E1. We don't need them. Copy the lines for E1, change the names to E2, and change the pins to the ones you have connected to, which is 40, 42, and 44. After the change, it will look like this. Now we can upload the firmware to Arduino. After that, connect the power to ramp 1.4, then you can test the motors. The Arduino is connected to your computer through a serial port. You can find the port in Arduino IDE through the Tools port menu. In the Python console, you import the serial library, initialize the port, then write G-code to Arduino. With this G-code, you should see the motor connected to X moves. The 3D printed parts include the box to hold the control board, the support for motors, and the caps to connect the motor and the Rubik's Cube. I designed them with Autodesk Fusion 360. Link to the STL files is in the video's description. After assembly, it looks like this. In the next video, I'll talk about the software.